With scientific notation. We can use our exponent rules to multiply and divide in scientific notation. So we're going to do an example here where we are multiplying in scientific notation. So what we're going to do is just rearrange things. Put our numbers without the exponents together. So I'm going to go 4.62 times 8.15, and then I'm going to multiply that times 10 to the 5th power times 10 to the 9th power. So if I multiply 4.62 times 8.15, I get 37.653, and you just type that into your calculator, times I'm going to use my exponent rules, and I can add my exponents. So 5 plus 9. So that's going to give me 37.653 times 10 to the 14th power. However, this is not in scientific notation because I can only have one number to the left of the decimal, so I need to move it one more spot. And because I moved it to the left, I need to add 1 to my exponent. So my final answer is going to be 3.7653 times 10 to the 15th power. And that is your final answer. Example 2. 7.53 times 10 to the negative 8 times 2.93 times 10 to the negative 3. So I'm going to have 7.53 times 2.93 times 10 to the negative 8 times 10 to the negative 3. So now I just have to put things together. So I'm going to multiply right here, and I get a 22.0629 times 10. And what I have to do with these exponents is I need to add them because they are a set common base here. 10 to the negative 8 minus or plus a negative 3. So that gives me 22.0629 times 10 to the negative 11th power. But again, we are not yet in scientific notation because this needs to be your only number to the left of the decimal. So I need to move it one spot. And if I move it one spot to the left, I need to add 1 up on my exponent. So that's going to give me 2.20629 times 10 to the negative 10th power. And that is your final answer. Next, we're going to divide two numbers. So we have 4.62 times 10 to the 5th power divided by 1.4 times 10 to the negative 9th power. So if we want to separate it out like we did before, we would write 4.62 over my 1.4, and I'm going to multiply that by my 10 to the 5th over my 10 to the negative 9th. Okay, so now if I divide out 4.62 divided by 1.4, I'm going to get a 3.3 times, now here, since this is a negative exponent, I can flip it up and then switch the sign. So I have 10 to the 5th times 10 to the 9th, flip the sign. So I have 3.3 times 10 to the 5 plus 9. So my final answer, 3.3 times 10 to the 14th power. And that is my final answer because there is only one number to the left of the decimal. So that's your final answer. And the next example here, we have 2.5627 times 10 to the negative 9th divided by 5.23 times 10 to the negative 3. So again, line up your numbers. 2.5627 divided by 5.23 times 10 to the negative 9th over 10 to the negative 3. Okay, so when I divide out my numbers, I would get a 0.49 times, and here I'm going to just flip the bottom one to get rid of the fraction. So I'm going to flip this up because it is a negative exponent and flip the sign. So I'm going to have 10 to the negative 9th times 10 to the positive 3, because you flip the sign when you flip it over the fraction bar. So we have 0.49 times 10 to the negative 9 plus 3. Okay, so that is 0.49 times 10 to the negative 6 power. But again, now we have to check my decimal. I do not have a digit to the left of the decimal here, so I have to move the decimal one spot. This time I am moving it to the right. So I need to subtract 1 on my exponent. So my final answer is 4.9 times 10 to the negative 7 power, and that would be your final answer. Adding and subtracting are a little different. When adding or subtracting in scientific notation, the place value is represented by the exponents, and the exponents must be the same in order to add or subtract. So we're going to do some examples of where we're adding or subtracting. So this one, we have 5.45 times 10 to the third power plus 3.12 times 10 to the fourth power. So we need to change one of the exponents to make it the same as the other. So if I choose to change this one, I need to make this a 3. So I need to subtract 1 from my exponent, which means I have to move my decimal 1 spot to the right because I subtracted from my exponent. So now I have 5.45 times 10 to the third power plus 31.2 times 10 to the third power. Now we have the same exponent, so we can add our numbers. 5.45 plus 31.2 times 10 to the third power, because they're both the same, and then I add my numbers together and get 36.65 times 10 to the third power, but I gotta have only one number to the left of my decimal, so I need to move my decimal 1 point to the left. So if I'm moving it to the left, I'm going to add 1 to my exponent. So I have 3.665 times 10 to the fourth power, and that is your final answer. For this next example, we want to add 0.00864 plus 5.67 times 10 to the negative fourth power. So I want to put the first number into a form where there's a negative fourth power. So I want to move the decimal 4 spots to the right. So that's going to give me 86.4 times 10 to the negative fourth power plus 5.67 times 10 to the negative fourth power. So then what I would have would be 86.4 plus 5.67 times 10 to the negative fourth power, because they're both the same now. When I add 86.4 and 5.67, I get 92.07 times 10 to the negative fourth power. But now I can only have one number to the left of the decimal, so I have to move it one spot to the left. So I'm going to add 1 to my exponent, giving me a final answer of 9.207 times 10 to the negative 3 power for your final answer. When we are subtracting, we do the same thing as we do with adding. Okay, so we have to make sure that our exponents are the same, and this one's got a 5, this one's a 4, so they're not the same. So we need to change our 2.78 times 10 to the 5th power to make it a 4th power. So I'm going to move it one spot to the right, and then I subtract 1 from my exponent. So that's going to give me 27.8 times 10 to the 4th power minus 4.65 times 10 to the 4th power. Now I have the same power, so I just subtract my numbers. 27.8 minus 4.65 times 10 to the 4th power. 27.8 minus 4.65 is going to give me a 23.15 times 10 to the 4th power. And now again, I need to make sure this is in scientific notation, so only one number to the left of the decimal, so I'm going to move it to the left 1. And if I move it to the left, I'm going to add 1 to my exponent. So my final answer is 2.315 times 10 to the 5th power. And that's your final answer. And my last example, I want to subtract 0.0000321 minus 4.9 times 10 to the negative 7th power. So the first thing I'm going to do is make my first number to be a negative 7th power times 10 to the negative 7th. So 1, 2, 3, 4, 5, 6, 7. I have to move it 7 spots to the right to get it to be a negative 7 power. So that's going to give me 321 times 10 to the negative 7th power minus 4.9 times 10 to the negative 7th power. So then I'm going to put my numbers together. 321 minus 4.9 times 10 to the negative 7th power. So 321 minus 4.9 is going to give me a 316.1 times 10 to the negative 7th power. But I need to put it back into scientific notation, so move it 2 spots to the left. So that means I'm going to add 2 to my exponent. So that's going to give me 3.161 times 10 to the negative 5th power, and that is your final answer. So those are your notes over operations with scientific notation. Go through some practice problems, make sure you can do all these different operations, and then you should be ready for your quiz.